If you can graph f of x, you can graph the absolute value of f of x. And all this will do is says in the absolute value of f of x, all you're doing is making everything positive, because that's what an absolute value does. So it will take all the negative parts of a graph and flip them over the x-axis. I'll scroll back up so you can see the title again. Absolute value function. So you can write this on page 323 if you like. Okay. So here's our first example. If you were given 2x plus 3 and you were asked to graph the absolute value of this, it could be done in two ways. But I'm going to show you our new technique first. Our new technique will say graph the original function inside, which I'm going to do in blue, which is 2x plus 3. 2x plus 3 is easy to graph. You'd have a y-intercept of 3 and a slope of 2 and it would look like this. Key points will be the x-intercept. So I'm going to label my x-intercept on here. It happens to be at negative 3 over 2 comma 0. But we could graph and we could label other points on here too, because I could just go down 2 over 1, down 2 over 1. So this point would be at negative 2, negative 1. Down 2 over 1, this would be at negative 3, negative 3. We have our original graph. Now in purple, an absolute value, what does it do? It changes negative numbers to positive and keeps positive numbers the same. And what's inside is the old y values. So basically, this is going to make all the y values positive. In other words, it's going to flip the negative part over the x-axis. So the positive part, which includes the 0 here, this whole section is going to stay exactly the same. I tried to overlap it, but so you still could see both colors. It wasn't the best. I apologize. Then the bottom part, if the y values are going to become positive, what's going to happen in negative 2, negative 1? It's going to become negative 2, positive 1. What's going to happen in negative 3, negative 3? It's going to become negative 3, positive 3. Your y values are going to get positive, and all that's happening is that bottom part is going to get flipped up. Okay? I think that's the best way to do these questions from now on. Now, do you remember in our very first chapter, you graphed the absolute value of x? So we could have done this question with transformations. But with transformations, you would have had to have factored out the 2. And you would have a vertical stretch by a factor of 2, and then you would have to shift it 3 over 2 to the left. You see the 3 over 2? But how much easier was it to just graph the inside, not have to worry about any of those transformations, And the powerful thing about this is we can put anything inside. So our next example, I took something from chapter 1. Let's say you had to graph this. X times x plus 3 times x plus x minus 2. From chapter 1, would you agree that these at 2 and at minus 3 and at 0, those would be your x-intercept because it's in factored form. And because it's an x cubed graph with a positive leading coefficient, you would know its end behavior starts in the bottom left-hand corner and ends in the top right-hand corner. So you could draw this graph like it's given to you right here. Now, over top of this, in purple, I'm going to do this. What does this do? It makes all your y values positive. If your y values were already positive, they would stay the same. Does that make sense? And if your y values were negative, they would get flipped over. And this would be our final graph if we had to do the absolute value of that original graph. And sometimes you're going to get questions where they give you f of x. Then they make you do the absolute value where you flip everything. And then they add a transformation after that by saying, could you take that whole thing that you flipped and move it down too? So, for example, I'm going to go back to the first one. So I'll give you some time to finish this one up. But I'm going to go back to the first one and add something to it. Everybody good here? If you need, I can go back to this at the end. So let's say they gave you f of x, which we drew in blue. Then they gave you the purple one, absolute value. And now they're saying, could you graph the following? Whew. So it's mixing the absolute value with transformations. This part right here is our purple graph. What do we need to do to the purple graph? If you put a negative in front, can you see that that would be a vertical reflection? That would flip this all upside down, which would make it all negative. Does it make sense that if you took something that was all positive and put a negative in front, it would get all negative? And then we'd have to shift it up 1 unit. So what would it look like in the end? Oops. Okay, it got flipped down, and then we shifted it up 1 unit. You see that your new vertex would be right here at negative 1.5, 1, and that it would be going down as a result. So I took this purple graph, I flipped it down, and then I shifted it up 1 unit, so this point here and this point here would now be those 2 points. So sometimes they mix things together, like they do an absolute value, but then add some transformations to it, sort of combining a bit of chapter 3 with this topic from our last chapter. And that's it. So, end the video here. Very exciting.